Is that bloody thing live now or not? Dear me. Is it working or not? Come on. Ah, finally, third attempt. Third attempt. Ah, right. So the materials that a friend sent me from America, I've put them in these jigs. That's the inner cores. The rest of the material, I put them in these jigs so I can take off 2 millimeters of the protruding parts, because the reason for that is that they won't fit inside my secondary bobbins. So if I get these these secondary bobbins, basically this is the same diameter. Well, actually, the problem is the material is too wide to go through the slots. Well, that's which way around is it? That way around, I think. Yeah. So because it's too wide, I don't know if you can see this, but and I'm not going to rewind all my coils, no way, but you can see the bit that sticks out, oops, there, is actually up against that plastic there. So this is flush on this side, and this bit sticks out a bit, so I've got to take 2 millimeters off so that all my coils will fit. And this is the nanocrystalline material, and what I was thinking about doing is taking most of it off on the grinder actually, and these plastic holders prevent these thin wafered sheets from peeling apart, because they are laminations. They're very thin, and it's pretty razor sharp. If you get your fingers on there, you can actually see on, I think it's that one, there's a bit that peel at the back there. I put some glue, some of my homemade ABS glue to stop them from peeling apart when I'm grinding them, but I've got to grind them down, and then I don't know yet. I was thinking about taking them up to engineering them, getting them to give them a nice flat surface on the horizontal mill using a grindstone thing, but I don't know yet. We'll see, because if they're going to charge me a ridiculous amount, I'm not going to bother. I'm just going to do it on my bench grinder. I'm just going to flatten it out. But my other materials have arrived from China, which is the ferrite material. I'll turn it around. So the ferrite material arrived, which is a lot easier to work with, because it's I've got a lot of them. I got there was 4 in each. I think it's 4 in each order packs, and I got several. So I think they've sent me a few extra actually. Not sure. Anyway, I've got plenty of ferrite, and this material, it's very brittle, so I've got to be careful. But the idea is that that two of these are the same width as the slots that are in the top of my steel corners, and they will slot in. I'll intersect them so it'll be something. I can't get these two out. I'll basically have something like that, where the two in the middle go into my core material. These two, oh, my finger is moving about. So these two intersect, then the others, and then it all goes through. Then I'll have then for the other side, my cores are going to be a lot longer, so I'm going to have more room for secondary cores and that. But they've got good magnetic field coupling on there. There's they're very good. It's very if I stick my magnet on there, you'll see how much flux there is, but they're very good for magnetic field coupling, and obviously because of ferrite, it's high frequency. So this is the stuff I was thinking about trying first, really, because I want to use that stuff, but this stuff here, which my friend sent me, but I'm going to need to do quite a bit of machining on it too. And the other material that was on the outside of the transformer is still in that thing, soaking in acetone, and it is peeling apart. And I would have to that stuff. I would have to trim that as well because it's a bit wide. I'll have to trim each individual one to take a couple of millimeters off it so that it fits well. But I was thinking about making some holders to hold this ferrite material, because it's I don't need to cut this. If anything, it's a little bit too narrow, but at least it's something I can get on with. And they're not antenna, they're not radio frequency ferrites, but they're I think they could be used for that as well, I suppose. But they are very strong when you stick a magnet on the end. I'll try and demonstrate that without shattering it. But if I get a magnet, let's just get one neodymium magnet without it jumping and shattering on me. Stick one magnet on the end there. Let's see if I can pick something up. Yeah, it's picked that up, no problem. You can see the magnetic field going through that is pretty strong. It's picked up a paperclip thing. So there's a good amount of flux can travel through these. Just a minute. Right, so I thought I'd give you an update on the core materials. So I've got to design a holder to hold these so that they will basically be in. Oh, I was going to give you an update on the other core that I stuck in there using just the other material that I stuck in there before. After I took the welding rods out, I used the metal spacers in there, and one of the things that I noticed immediately was that they're in much better resonance, that they do work a lot better, and my input current hardly fluctuates at all. I'll just turn it on. No, I'll just get that going. I think my nickel metal hydride batteries are across the room there, which actually just power the circuit on this. They don't actually send power to the MOSFET output, they just drive this circuit. So previously, I think this uses 20 milliamps. I was wrong actually. I think this circuit on its own uses about 50-60 milliamps, but it's not the power that goes in from the nickel metal hydrides. Originally, when I designed this board, I did explain previously that there's a high voltage boost on this circuit using an NE555, which doubles up voltages to basically send a high voltage to the output stages. Well, that's not being used because it's detuned right now, so it's been turned basically to a very low frequency, so it doesn't provide the power, because all the power I want comes from here. The reason why I don't want that is because I want to be able to measure it, and I can't measure it when it comes from this thing. So if I switch that on, we're currently running at 31.5 volts. It's jumping around a bit. But if I was to turn this trimmer pot here clockwise, it would get HT from here. But the trouble with that is there's no control on the voltage, and the voltage has got to be very accurately tuned to optimize this circuit, which is why I'm not using the high voltage section of this PCB, this circuit board. It's basically disabled. If I was to turn this thing off again, right, it's turned off now, there's no lights lit up there. And then if I was to power it up with my nickel metal hydride, like that, right, it's on right now, you'll notice that we've got absolutely no output there. Right, it's not showing the needle moving at all though. Right, Now as soon as I turn the juice on here, because this is disabled, this part, so as soon as I turn the juice on, right, now you'll see we have 200 milliamps. This needle wants recalibrating on this meter because I've knocked it again. I dropped it on the floor the other day and I think I'm going to screw it up, but input current at the moment is 70 milliamps on the high side, so 31.5 volts, 70 milliamps, and it's resonating the circuit. And now if I was to turn this trimmer up, we'll see the current on this side will start to drop because it will start to take power from here. So if I just do that quickly, just to show you what I mean, if I actually engage this high voltage section here, you'll see the current on there drop. It's at 70 right now, so if I turn it up, you'll see it's dropped now because it's getting power from the nickel metal hard drives. I don't want that to happen, so I'm going to turn it all the way off because I just want current from here so I can measure it. You see, I can't measure it if it's going through here because it's up the nickel metal hard drive basically is running this thing. So as you can see, we're pushing it about it says 180 milliamps, but that meter wants calibrating. I've knocked the damn needle a bit off. Let's just unplug this thing. Right, the needle is at naught, is it? Oh, that's good enough, it's at naught. Right, plug that back in again. Right, so that's what we're at the moment. So that power's going up to the into the supercapacitors right now. Yeah, so I wanted to show you that briefly, but when we're at the minimum voltage we do get I mean, we're going into about 3 volts right now. If we turn this meter on, we're actually going into about 4.87. It's climbing as the capacitors are charging, it's climbing the voltage. So we're going into about nearly 5 volts. Because the supercapacitors are basically completely flat right now. So it's slowly climbing up as it's charging them up. And I got this tuned a lot better, so it's interesting what goes on right now. Because if I took the load off, completely took the load off, the input current will go right up. Well, two things happen now. If I short these AC outputs on here, right, short these like that, the input current goes down. If I short this other one, input current goes down. Also, if I take the load off completely, take this lead out and watch the needle, I've taken the load off, input current goes down. So yeah, it's gone down to 70. I'll plug it back in again. It's gone up a bit. So we've got a better balance on the system right now. So we're back plugged in again. So it's interesting how this basically works right now, because if I short it out completely, put an extremely high load on it, my input current goes down. And if I take the load off completely, the input current goes down. Which is strange. There's two sides of this phase, whatever, whereas if there's no current load, then the input current goes down. If there's a really excessive load, the input current goes down as well. So yeah, it's working much more uniformly than it was with the cores that had the copper, the welding rods, basically these things. When I had these in there, there was a much higher input current when there was no load on them. When I took these out and put the other material in, which is basically steel shims, it works better. So I thought I'd explain that, because I was going to show you that before, but I forgot about the input. So basically the way this is set right now, I don't see the input current go anywhere above 90 milliamps max on the output. Although as the supercapacitors charge, as they charge up, we start to lose output, and it'll start to drop from around 200 milliamps minimum when this voltage is on the supercapacitors at the very lowest. It will drop from 200 milliamps into the supercapacitors, it'll drop right down to about 100 milliamps when we get to full charge at about 12 volts. 13 volts I think it is. We'll get to about 100 milliamps to 90 milliamps on the input, on the output, sorry, the output to the supercapacitor. So yeah, and then this side doesn't change much. It'll vary between around 70 milliamps to 100 milliamps. It won't go any higher than that on the input. So that's encouraging, because it means I've got a better balance on the system. Well, we're going to see all that change. We're going to see all of that change once I try other materials, obviously, like either the ferrites or the nanocrystalline. What I was planning on doing was to grind this down. I want to get this, as I said, take 2 millimeters off this side. And if you look, there's some slots in here which are for a hacksaw blade, and I plan to split this so that there's 2 corners. So right angle corners. So this is going to be made into 2 corners, so that I've got new corners on up here, and this should be long enough coming down to reach into my output coils, and this will meet up with one of the other corners on the other side, and this bend is what's going to face up against the actuator coils. So this basically will, if you imagine I chop that piece off there like that where my thumb is, it's going to be like that, facing down into the core, and this bit that's sticking near my thumb will be facing towards the actuators. So that's the idea. That's what I want to do. And then obviously I'll have 4 of these instead of 2. Instead of these two, I'll have 4 corners instead. So I decided to use this, and I don't want to split the material into layers, because I haven't got the equipment to flatten it and squish it all back together again. So I decided I was going to keep it in this shape, just skim off that surplus that's sticking out. So then I'll put them in a new holder, a new corner holder, and mount it on there. That's what I want to do. But it's a lot of fighting about, because to grind 2 millimeters off both of these on my bench grinder, it's going to be taking me a while to do, because it's going to get hot and I'm going to have to stop. What I was thinking about doing was swapping, basically doing one, then putting it down while it cools a bit, put it in cold water, then grind a bit of the other one, and put that one in cold water, then grab the other one and grind a bit of that, and alternate until I get it ground down, because it's going to get pretty hot on the bench grinder while I'm doing that. So I'm going to alternate and do one at a time, and then swap until I get it down the material. It's going to take me a while, I suppose. Grinding 2 millimeters of material off there is going to take me a long time, probably. But the ferrites are going to be fun to do, because I'm not going to cut these. I'm just going to, if anything, I'm just going to extend the core section. I'm going to make it a bit longer so I can actually get more secondaries on there, because I don't want to cut that ferrite material if I can help it, because it's got nice straight edges on there. It's got nice straight edges which will meet up better, and besides, having a bit more length to it, I don't see that's going to be a problem really. Sorry, I'm not pointing at the right place. So anyway, that's all for now. I tried 3 times to go live, and it was messing me about, and the longer these live streams are, the longer it takes to encode, so I'm going to end it there. And oh yeah, a happy new year and Merry Christmas to you all. I think we're about a week away from Christmas now. What's the date today? I've forgotten. Well, 18th of December, so let's see, that's 7 days away. Yeah, so about a week away from Christmas Day. So yeah, I'll just wish everybody a happy new year and Merry Christmas and everything. Well, while I'm here, might as well. Okay, bye for now.